Hi, my name is Nidzaree and Maulana, and today we all gonna talk about the memory system related to our subject microprocessor. Here we're gonna discuss about types of memory and memory mapping and management, and of course the cache memory and its importance. So without further ado, let's discuss this. What is memory system? Memory system includes various types of memories like RAM or random access memory, ROM or read-only memory, and flash memory. These components works together to store and retrieve data for processors to execute instructions. The definition of memory system is that it refers to the collection of components within a computer or electronic devices that stores data instructions for processing. More about this subject, we have to know what are the different importance of memory systems when understanding the subject microprocessor. Importance of memory system to microprocessors: understanding system architecture, efficient programming, memory interfacing, and performance optimization, and last is system debugging. A student needs to grasp how different types of memory is used in a system and their roles in data storage and retrieval. And also they can optimize their code by understanding how different types of memory are accessed and used by the processor. And understanding the memory interfacing is crucial for students to design systems that they can store and retrieve data effectively. Overall, a solid understanding of memory systems is essential for the students in studying microprocessors. It forms a foundation or founding for designing efficient and effective computing systems. Types of memory. We have to focus in these three types of memory for this discussion. First is random access memory or RAM, read-only memory or ROM, and flash memory like USB drives and SSDs, etc. Random access memory. Volatile memory used for temporary storage. Faster access compared to other memory types. And to proceed in RAM or read-only memory. Non-volatile memory used to permanent storage. Contains firmware or boot instruction. And last is the flash memory. Flash memory, of course, is non-volatile memory used for storage in devices like USB drives, SSDs, and so on and so forth. Memory mapping and management. It has a lot of techniques, which includes direct mapping. Each block of main memory is mapped to exactly one cache line. This mapping is determined by the last significant bits of the memory address. Associative mapping. Each block of main memory can be mapped to any cache line. This mapping is determined by the content of the memory block rather than the memory address. Set associative mapping is a comparison between direct mapping and associative mapping. It drives the cache into sets, with each set containing multiple cache lines. Virtual memory mapping allows the operating system to map virtual memory address used by a process to physical memory address. Cache memory and its importance. Cache memory is an extremely fast memory type that acts as a buffer between RAM and the CPU. Cache memory holds frequently requested data and instructions so that they are immediately available to the CPU when needed. Cache memory is typically divided into three levels, consists of L1, L2, and L3. Each level represents different proximity to CPU and has varying sizes and speed. And here is the importance of cache. First is faster access to frequently used data, reduces a latency between the process and the main memory, improves overall system performance. So these are the three main importance of cache memory. That's all for memory system. Memory system is one of the topics to be discussed in the subject microprocessors. And let us not forget that this video is for educational purposes and as a requirement to be submitted to our subject, microprocessors, handled by our instructor, Sir Engineer Alex Remegio. Hope you learned something in this video presentation and wish you all the best.